rotate.
How can one single village be completely washed away by a flood, while the house just 500 meters away stays perfectly dry? The answer is a cloudburst, a weather anomaly so localized and so violent that it can drop an entire month's worth of rain in just 60 minutes. Imagine standing beneath a dark mountain sky. Within minutes, rain begins to fall so heavily that roads disappear, rivers turn into raging torrents, and entire hillsides start collapsing. This is not an ordinary rainstorm, it is a cloudburst, one of nature's most sudden and destructive weather events. So, what is a cloudburst? A cloudburst is an extremely intense rainfall event that occurs over a very small area, usually lasting from a few minutes to about an hour. During this short time, an enormous amount of rain falls so quickly that the ground, streams, and drainage system cannot absorb or carry it away. Meteorologists often describe a cloudburst as rainfall exceeding 100 millimeters, about 4 inches in 1 hour, over a localized area, although the exact threshold vary by country and weather agency. Unlike widespread storms that affect entire region, a cloudburst is highly localized. One village may receive catastrophic rainfall, while another just a few kilometers away experience only light rain. So, how does a cloudburst happens? A cloudburst forms when several atmospheric conditions come together at the same time. Number one, warm, moist air rises. The process begins when warm, humid air near the Earth's surface starts rising into the atmosphere. As it rises, the air expands and cools. Cooler air cannot hold as much water vapor, so the moisture began to condense into tiny water droplets, forming clouds. Second, powerful updrafts keep water suspended. Inside developing storm clouds, strong upward moving wind called updraft drafts continuously lift water droplet higher into the clouds. Normally, raindrops become heavy enough to fall, but during a severe thunderstorm, these powerful updrafts keep lifting them back upward before they can reach the ground. As a result, more and more moisture accumulates inside the cloud. Number three, the cloud stores huge amount of water. Over time, billions of tiny droplets merge into large droplets. The storm cloud becomes like an enormous reservoir suspended in the sky, containing a tremendous amount of water. As long as the updraft remains strong, much of this water stays trapped inside the cloud.
Number 4. The atmosphere can no longer hold the water. Eventually, the water droplets become too large and heavy for the rising air to support. Sometimes the updraft weakens, sometimes colder air enters the storm, sometimes the cloud simply reaches its limit. And when this happens, the cloud releases an enormous amount of water almost all at once. Instead of steady rainfall, the result is an intense downpour concentrated over a small area, a cloudburst. So why do cloudbursts often happens in mountains? Mountain region experience cloudbursts more frequently because of a process called orographic lifting. When moisture rich wind encounters mountain, they are forced to rise rapidly along the slope. As the air rises, it cools quickly, water vapor condenses rapidly, large thunderclouds develop, heavy rainfall become much more likely. This is why cloudbursts are common in places such as northern Pakistan, northern India, Nepal, Uttarakhand, Himachal Pradesh, and Kashmir. These regions combine steep terrain with abundant monsoon moisture, making them particularly vulnerable. So, why are cloudbursts so dangerous? The danger is not just the amount of rain, it is how quickly the rain falls. The ground simply cannot absorb water at such an extreme rate. Instead, nearly all of it becomes surface runoff. Water rapidly flows downhill, gathering speed and volume. Small streams become raging rivers within minutes. Roads become channels for fast moving water. Bridges experience tremendous hydraulic forces. Entire valleys can flood because before residents can even realize what is happening. So, what happened after cloudburst? The rainfall itself may last only a short time, but its effect can continue for days, weeks, or even years. Flash flood. The most immediate consequence is a flash flood. Water races through rivers, streams, streets, and valleys with tremendous force. A flash flood develops within minutes, giving people very little time to react. Vehicle can be swept away, buildings can collapse, entire neighborhoods may become submerged. So, damage to dams and hydropower projects. Cloudbursts create major challenges for hydropower infrastructure. Large quantities of mud, sand, gravel, rocks, tree trunks, and branches rush into reservoirs. These materials can block intake structure, damage trash tract, increase sedimentation, reduce reservoir storage capacity, cause turbine erosion, and increase wear on spillway gates and outlets. Operator may need to perform emergency sediment flushing or increase spillway release to safely pass the flood. A localized cloudburst occurred upstream of the dam, triggering a sudden flood that carried enormous amount of silt, mud, and debris into the reservoir. Within a short time, the normally clear water turned brown as suspended sediment spread throughout the reservoir. To manage the incoming sediment load, the dam operator began opening the radial spillway gates in a controlled manner. This allowed the sediment-laden water to be released downstream, helping reduce the buildup of mud inside the reservoir and maintain storage capacity. At the same time, the Undersluice gate were put into operation to flush out the heavy silt that had accumulated in front of the intake structure. This is essential because excessive sediment near the intake can restrict water flow and affect the safe and efficient operation of the hydropower plant. The flood also carried large amount of floating debris, including tree branches, logs, and vegetation. To safely remove this material before it could collect near the intake or damage equipment, the flap gates were opened. The floating debris were then guided out of the reservoir, with the flowing water helping keep the dam intake area clear and ensuring reliable operation throughout the flood events.